CGMS students, welcome to classwork homework 7.2. Watch the video, check off. It is due Monday when we get back, April 1st. You work really well during this time. You'll probably have no homework. So, as you recall from yesterday, our circumference formula, aka the distance around a circle, so kind of like perimeter, is equal to C is equal to pi times our diameter, pi being 3.14. Our diameter being the length all the way across a circle. Or you could also use the formula C is equal to 2 pi r, r being the radius, a distance that's halfway across the circle. Makes sense because 2 times r, 2 times the radius, would give you a diameter, right? Now, the area of the circle, or the space inside of a circle, is the formula A is equal to pi r squared, the radius squared. So you cannot use a different number other than the radius for that formula. So only one formula. So let's do a couple practice problems before we try and get some real world problems. So it says, what is the area of a circle with a radius of 6 centimeters? So because it says area, and we're working with area, we're going to use our area formula. Area is equal to pi r squared. Cool. It now tells us that we have a radius of 6. Basically, all we're going to do is plug in, instead of r, we're going to put 6. So area is equal to, we'll say, 3.14 for pi times 6 squared, right? And you can type this all into your calculator in one swoop. The exponent button is right to the left of your 7 there. If you wanted to show order of operations, area is equal to 3.14. Do the exponents first, times 36. And area is equal to 113.04 centimeters squared. So C is your answer. And what this means is I can fit inside of a circle with a radius of 6, 113 1 by 1 square centimeters. Hence why we say our answer is squared. Okay. Number 2, it says calculate the area of a circle with a diameter of 14 inches. Might be helpful to draw this one out. So we got our circle, and this time we have a diameter, something going all the way across a 14. Now remember, in problem number 1, we had a circle but with a radius of 6, right? So if I have a diameter equal to 14 and I want to work with area here, well, the area formula tells me I need r, radius. Well, if my diameter is 14, my radius has then got to be half of that. So what is half of 14? What's this just point right here? It's 7. 14 divided by 2 is 7. So area is equal to pi r squared. That's our formula. Area is equal to 3.14 times 7 squared. And we just use our calculators. And instead of using order of operations, I'm just going to do it in one big swoop. So area is equal to 153.86 inches squared. So C. Okay. Last one I'll do with you is actually not going to be number 3. Not going to be number 4, because those are exactly like 1 and 2. In fact, 3 you'll do a Ned puzzle. And number 4 you'll do a Ned puzzle. Remember to write your work on the paper. We're going to do number 5 with you. So when we have a circle with a grid here, we got to find the center of the circle, which is right here. And then we're going to count how many units the center is from the edge. So we got 1, 2, 3, 4 units. So that means it has a radius of 4. So now we're going to say, it says what is the area? So A equals pi r squared. We know that A is equal to 3.14 times 4 squared. When we do that, area is equal to 50.24 units squared. Notice they didn't tell you it was inches or centimeters or anything like that. It's just, if I count all the squares inside the circle, I can put 50.24 1 by 1 squares in there. Number 6, I will have you do in a puzzle. Now, it's not always about area. In fact, in these problems, I want you to find the circumference. Remember, circumference formula back up at the top, it can either be C is equal to pi d or C is equal to 2 pi r. You don't have to do any thinking. So in this case, number 7, they gave us a radius. It has a radius of 4. So it would make sense to use C equals 2 pi times the radius, since we have what the radius is. So C is equal to 2 times 3.14, and you could write these all in parentheses if you want, times 4. And you can do that all in one swoop, and you get the circumference of this circle as 25.12 inches. So B. Notice how our units here are not squared. That's because we're talking about the distance around the circle, not the space inside the circle anymore. Number 8, I will allow you to do an Ed puzzle. All right, on the back side, we're going to do real-world application. I'm going to do one of these problems with you, and then I'm going to ask you to kind of really struggle through a couple of problems on your own. All right, so drawing pictures is going to be key. It says a cell phone tower picks up signals within a 65-mile radius. When they're talking about radius, they know you got like a tower here with a circle of 65 miles. All right, so with a radius of 65. So what do I know? I've got a radius of 65 miles. How many square miles coverage does the cell phone tower provide? Since it's talking about square miles, not just miles, it's talking about square miles. Square miles means that we are asked for our radius. Any square units, sorry, not our radius, our area, my fault. Any units squared is going to find out our area. Any regular units, that's our circumference, right? So what do I need to know? I need to know the square area of coverage. So since I'm working with area, plan it out. Let's draw a picture. Here's our cell tower. It can go 65-mile radius, right? And that means it can go 65 miles in any direction. So we should get this nice circle. Maybe, hopefully you draw yours a little bit nicer than mine. So what is the area, the space inside this circle, right? I got a radius. So area is equal to pi r squared. Area is equal to 3.14 times 65, my radius, squared. Area is equal to 13,266.5 square miles, right? So my solution, 13,266.5 square miles of cell phone coverage. It's good. We want a big space of cell phone coverage because then our phones would constantly be going in and out. All right, so drawing pictures is key. Like this part is the most important part. Being able to draw a picture of like what's going on, and then picking the right formula is the next key thing, and then obviously plugging in your known variables. Okay, so for number 2, figure out, are we talking about area, right? Are we talking about circumference, right? If I'm just asking you how far something travels in a certain amount of units without them being square units, it's definitely circumference, right? And then number 3, a little bit challenging there for you. It says how many more square feet? Square feet. Hello, area. Will the larger fountain occupy than the smaller? So you might have to do some, even though one circle looks bigger than the other, I don't know. You might have to do some math with them, right? Maybe find the area of one, maybe find the area of the other, figure out how much bigger one is than the other. That's it.